And hello, welcome everyone to this video of Labview. Today I want to talk about how to package your simulation system into something really neat. It's called a simulation subsystem because if your system gets really complicated and you want all of your simulation subsystems to be in a while loop, neatly packaged, you can do so using simulation subsystems. So I'm going to introduce you how to do that. Introduce to you how to do that today. Yeah, it's something I want to show you. And before I start, I want to give credit to this gentleman. I think his name is Hans-Peter Halvorsen. Okay, Hans-Peter Halvorsen. I'm not sure how to pronounce his name properly, but he has a blog and it's all about Labview, and he looks like he's really good at this stuff, and he has a very comprehensive slides and all that. I'll paste all the links here in the description. So if you want to learn more about Labview, do go and check his website out. I think he's way more experienced than me. I'm just here doing videos as I learn, and I'm posting videos up so that I don't forget later. And of course, if you find it beneficial and helpful in trying to figure your way out around Labview, by all means, come and take a look. Yeah, but I'm no expert, okay? I'm no expert. Just giving credit to him for this video. I'm sure there are lots of other people who know how to do this as well, but he's really good. And one more thing. Actually, I wanted to do this heater so-called heater example, right? However, there are already a lot of examples here. Okay, in case I don't find the time to post my heated tank example up and learn to do it from scratch. I mean, I hope to, but in case I don't, just want you to know that there are lots of examples here inside the inside the control and simulation suite. Okay, you have simulation, control design, and algorithms, but you also have case studies. And in case studies, case studies, you are able to see lots of different sorts of examples for this control and simulation. They are way more complicated than what we see. So for example, you can see process control. You can take a look at reactor distillation system. This one's a very interesting one for chemical engineers. So you see there's this whole distillation column and this CSTR over here, and lots of valves you can control. Some, they will have gauges for feed rates and everything, and even a 20 stage distillation column, 21 plates it looks like. So it's pretty juicy stuff. If you want to take a look at it, but if it causes you headache, by all means just feel free to skip, unless of course you need to do it for homework, then I can't really help you there. There's also an air heater, which is what I'm trying to talk about. It's a Labview project, which is way more complicated than just one VI. It's several VIs packaged together. And what it allows you to do, is, let's see if there's a main VI, air heater controller supervisory. Okay, let's try this one. Yeah, so it's a way to basically there's a very complicated air heater design here. You can go and take a look. It's very complicated, not like what I'm intending to do. It's way more complicated than what I'm doing. So I mean, it's something you can take a look at, and you can just press play. Okay, I don't know exactly what it's supposed to do at this point in time, but I just want to say it's there. Okay, it's there. Now, onto the video proper. Let's see how much time I have remaining. Okay, 15 minutes should be enough, I hope. Okay, how do you package all your sub VIs? Okay, how do you package your control loop? Okay, all these transfer functions, everything that was doing in the last few videos. How do you collapse it into this sort of a format? Okay, so there are a few things you need to do to start. Okay, again credit to Hans Peter, I think Halvorsen. Sorry, Halvorsen. If I butcher your name and you're watching this video, I'm so sorry. No hard feelings intended. Okay. Anyway, so how do you do it? Okay, so there are a few simple steps that you need to follow. There are lots of, but there are a few concepts. Okay, we have not quite touched on them. Okay, in the previous videos. All right, so so I left this example here. I'll probably add it to GitHub later on. But what you can do first is to create a new folder, and we are going to make a new Labview project. So I'll do this thing, demo YouTube Sim Subsystems. Okay, demo YouTube Simulation Subsystems. I'll make this folder over here. What we want to do here is to create a new Labview project. Okay, don't save. Okay, so I want to create a project. Okay, so we'll make a blank project. We'll make a blank project. And what we are supposed to do here, we'll just save this blank project over on this demo YouTube Simulation Subsystem, because I'm demonstrating this on YouTube. So demo YouTube Sim Subsystems. Okay, if you want to try this at home, you don't have to pay the money that Labview is asking for, the license, because they have this thing called Labview Community Edition, which as long as you I mean, yeah, you can go search that online. It's basically a non-commercial version. Okay, I'll talk about. I'm not going to elaborate on it here. I'm going to go back to the topic. Okay, let's go back to the topic. So let's go to this part on computer. Right-click the My Computer part. You just put a new Simulation Subsystem. Okay, again, as long as you have the Control Design Simulation module, right-click My Computer, go to New, and you go to Simulation Subsystem. Alright, and you notice in here everything in the block diagram is yellow. So I'm going to save this. Save as okay, demo YouTube sim transfer function. Okay, so this is where we're going to paste all our transfer function stuff. Okay, so right, this thing is going to be here, and you're going to be able to paste everything in your control design and simulation. Anything that's inside your simulation loop that's covered by the yellow bits can be put in here. So okay, let's do that. Okay, let's go up, and we'll go to YouTube Simulation Gen. I mean the demonstration. So this is everything inside your control and simulation loop. Okay, of course the juicy bits are over here. This is the part where most of the work has gone to. Of course there are local variables and such, but in simulation subsystems you cannot use local variables, and you don't really need to for the most part. Okay, so what I'm going to do, I'm going to copy this case structure, and I'm going to paste it inside the simulation subsystem. Okay, so I'm going to paste it in the simulation subsystem here. So copy and paste, nothing more than that. I'm going to save. Okay. Now first thing first, you'll notice that all of these lines are now broken. So you'll need to do a few things. Okay, you need to do a few things. You'll need to create a indicator here. Oops. Oh, sorry. No, I want to do a control. Sorry. You create a control here. So it's called select transfer function type, and you'll also right click and create this control over here. And this will be the transfer function input. Transfer function input. Okay, and over here you will have indicator, which is a transfer function output. Okay, nothing more than that. Okay, so we are basically doing we are cutting this part out, and then we want to compress it into the while loop over here. Okay, so that's the basic idea of what we are trying to do. Okay, so I'm going to close this bit, and okay, so I'm going to close this bit as well. Okay, so right, everything, all of these values will now be available for editing over here. Okay, so now what do we do? Okay, the next step, okay, I'm trying to go in a more intuitive step. Okay, I'm not going to go step by step, that kind of thing. I am going to go step by step, but I'm not going to go through like, oh, you need to do this A, B, C, D, E. I'm going by the rough concept. Okay, the rough ideas of what you need, the overall guiding ideas of what you need to do. So anyway, we have already created this subsystem. Okay, it has the inputs here, the select transfer function type, and of course your relevant outputs. Okay, if you want your nice graph, so what you can do is also you go to control and simulation, and what do you do? The graph utilities, go to sim time waveform, you put it here, then you just wire this up, and you'll have a waveform chart here, no problem. Okay, that's if you want your nice waveform to be piped out of this, and then you can see in your main interface. Okay, so this is one. This is the so-called module or the subsystem. Now it's finished. Okay, how then do you pipe it through, Labview? Okay, how do you pipe it through Labview or something like that? How do you put it in your while loop? Okay, I'm going to close all of this. I'm going to simulation this one. I'm going to open up the Labview project again, and now instead of editing this, we'll edit by making a new VI, and let's call this VI. We'll call this VI the demo YouTube main interface. So this is where you're going to see all your graphs, and you also make your while loop over here. Now to save us some extra time, we are going to copy and paste the while loop that we were constructing the last few videos. So this is the while loop that I want to copy and paste. I will not use it as is. There will be some edits I'll be making. I'll copy this. Now I'll put it on the main interface here. So okay, that's the main interface. I'll save it first, and then I will close the rest of the things. Okay, good. Now question is, how are we supposed to put the sub VI in here? Okay, how are we supposed to put the sub VI in here? So alright, how are we supposed to put the sub VI in here? So let's see. Okay, so this will be your front panel. Okay, everything is nicely copied and pasted here. We'll edit this again later. Okay, so I'm going to close this. Now question is, yes, how do we put the sub VI there? Okay, so let's open the main interface. Oh, this is the main interface. Okay, so this is the main interface. How are we supposed to put the sub VI here? Okay, very simple. Right click, and under your palette, go all the way to the bottom where it says select a VI. Okay, again, right click, under functions, go all the way to the bottom and click select a VI. And the VI you want to select is what you made just now, what we made just now, the demo YouTube scene transfer function. Okay, I'm going to click OK, and then the whole thing is going to appear here. Okay, now of course you want your output over here. Okay, and we are not going to, like I said before, we are not going to use local variables anymore, so I'm going to delete off all the local variables. Okay, including this waveform chart one. and this input UT. I'm going to delete this. I'm going to delete that. Now normally you're supposed to wire all these inputs and select transfer function type into this little VI. Okay, we like to call it, sometimes we like to call it sub VI, but this is not exactly a sub VI. This is a subsystem. Okay, normally there'll be some wired inputs. All right, wired inputs that are in this sub VI. Okay, there's still time. Yes. 5 more minutes. Okay, so now there are some wired inputs in this sub VI. How are we supposed to make the wire input so that we can put all these inputs in? Okay, so sometimes in a sub VI you will normally double click and it will allow you to edit the sub VI. Not so with this. This one you'll kind of have to right click and then you go to this open subsystem. Again, right click your simulation subsystem and go to open subsystem, and then this interface will pop up. Then now you can edit things inside your simulation subsystem. Why is it a simulation subsystem? Again, everything in here is yellow, which is indicating the simulation subsystem. Okay, so what are we supposed to do here? Now notice the top right here, there are lots of boxes. Okay, there are lots of boxes here. Usually the left sides of the boxes are for inputs and the right side of the boxes are for outputs. Okay. Yeah, again, usually the left sides of the boxes are for inputs and the right sides of the boxes are for outputs. So what are your inputs? Okay, your inputs are, well, you want to have a numerical value for your transfer function input, and you want to select your transfer function type. So those two are your inputs. So on the top leftmost, I want to put my transfer function input. So I'm going to click on this blue box here, or this box that is just highlighted, and then I'm going to click on the transfer function input because I want it to be wired to the top left. Okay, so it's going to wire. It's going to make that wire, and now you see this box turns orange. Now when you look over here at your the main interface, so to speak, this transfer function input wire pops up. So this gives you an idea of how to create terminals and wirings. Okay, so we can do the same thing with the rest of the inputs and outputs. So no problem. We'll do the same. So let's take a look at we'll open our subsystem up, and we'll do the same, the following. Okay, so select transfer function type. So again, you click the box over here, and you click this select transfer function type. Okay, this is very similar to what you do in a sub VI, but if you're not sure how to do sub VI, yeah, this will give you an idea of what to do inside there. Okay, so okay. And then we can also do the transfer function output. I'll put it on the top right. Okay. Okay, and I'm going to have a bottom right, so to speak. At the bottom right, I'm going to wire the output of this waveform chart. Okay. Okay, so now everything's done nicely. I'm going to save and I'm going to close. So let's wire these things in. So select transfer function type is over here. Okay, maybe I kind of well, the order was kind of reversed from what I intended, but okay, what the necessary inputs and outputs are already here. So let's wire the waveform chart to this transfer function waveform chart, and this transfer function output to this indicator here. Okay, so I'm going to go Control E, go to the front. This thing can, I think, kind of delete. No, I do not want to delete. Yeah, I do want to delete that. Okay, so my transfer function to waveform chart is there. Okay, this thing can be deleted. I don't think there's a need for that anymore. And this will be where I select my transfer function type. this is the value of the transfer function, or we can switch it around maybe to use a gauge or something like that. Okay, now this is not really necessary, but okay, never mind. I'll leave it as a numeric indicator, and basically we can just press play. Okay, press play. So this is a transfer function equals to 1. So that means as I shift this this slider up and down, it will vary between 0 and 10 without any delay. Then I can go and do this first order with delay example. So I'm going to shift it up to 4, and then you'll see this you'll see a slight delay, a 1 second delay, and then it will start to shift up and down. Of course, having a 3 second delay is much better. And now, of course, you see the timing here again doesn't quite synchronize properly with what is what's real time anyway. So anyway, that one we will worry about later. But at least these things are working correctly. The sliders, if you want a second order with transfer function, it will also work properly. So yeah, this thing will need to slow down later on, so we'll worry about that later. But meso transfer function, okay, you will see our jagged inlets and outlets. Okay, inputs and outputs will be sort of jagged because we added a noise signal. Alright, so now I think yeah, you have a transfer function equals to 1, then we can just shift it up and down. Okay, so I think that's all I want to share. We'll deal with this time issue later on, but you can see the latency, the lag is very low, and more importantly, we have effectively cleaned up the whole block diagram. So now this thing looks very simple, very neat, and that's important if you have a lot of components here. For example, like if you were to take a look at okay, if you were to take a look at some of these Labview examples over here, I'll go to control in simulation. You go to the case studies. Okay, in real case studies, your block diagram will be huge. So you take a look. This is a very messy block diagram. So you don't really want this kind of thing to happen. Okay, you don't really want this kind of thing to happen. As far as possible, you don't want excessively huge block diagrams which are very hard to read. As per this, and this one's already considered a neat block diagram because all of these for example the reactor CSTR1, okay, all of these have been simplified to this subsystem. Okay, if you open up the subsystem and you go to the block diagram, you'll notice that there are lots of stuff that's going on in here, that if you were to not put it in a block diagram, or you were not to put it in a subsystem, then it will be very, very messy. So that's the use of subsystems, is to like clean up your whole block diagram for you. Okay, so of course, let's see how much time there is left. Okay, it's 23 minutes. Okay, I'll stop for now. I guess I'll see you guys next time. Thanks for watching.